In this video, I discussed Joule thief circuit, blocking oscillator, Joule ringer, vampire torch circuit. It is a very simple and interesting circuit. It uses low voltage source to run high voltage load. Here I am using 1.5 volt battery and this circuit is producing 19.8 volt that is driving the load. Explained its working, then I designed this circuit practically, and after that I analyzed this circuit using oscilloscope. Let's start this video.
Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. Joule thief circuit, blocking oscillator, Joule ringer or vampire torch or self ringer, self oscillation circuit. It is a question from my viewer. Sir, I send you a question having subject Joule thief circuit. Please consider that question. It is very simple, very few components based self oscillation circuit. Its theory is very simple but a little bit confusing. I will try my best to explain it in so simple ways that you will follow it. This video will be in 3 portions. First I will explain the theory, then we will design it, and in the last portion of the video we will analyze this circuit and we will see the wave shapes and frequency and everything on oscilloscope. Basically it uses a transistor, NPN transistor, any NPN transistor. This time I am using C945, 2SC945. When we will provide a base biasing signal, it will start to flow base to emitter current. When a small amount of current will flow between base to emitter, it will allow a large current between emitter to collector. Here it will use 2 coils. One is called primary, second is called secondary. Both coils are on one core. Here a resistor is connected, 1 kilo ohm. A battery will be connected here, 1.5 volt battery. Basically this circuit is a simple voltage booster circuit. 1.5 volt battery is connected here. It will allow to turn on its oscillation. Initially when we apply voltage here, we can see at this positive side this inductor and then collector. Collector to emitter, no current will flow here until the base is biased up. For example, this is base. Until the base will receive more than 0.7 volts, that are the junction voltage, before 0.7 there will a minority current carrier. When the voltage will exceed then 0.7 volt, we can say the minimum startup voltage are above than 0.7 volts. When it will start to flow a current here, at that time this current will flow. That means when IB will start, at that time IC will start, collector current will start. Now here is a very simple technique that these both windings are opposite in direction. Opposite winding. When current will flow here, This end is now negative, this end is positive because it is closer to battery positive terminal. This current will start to build magnetic field in this winding, in the core. That magnetic field in the same time will produce voltage in this winding, secondary winding. Because the winding direction is opposite, that means if this end is positive, now this end will become positive. So voltage at base will start to increase. VB, so base voltage will start to increase until the IC is reached at saturation point. The maximum current will flow. In the first phase, until here, it started in linear conduction mode. But when this current started to flow, this current caused to produce voltage and it is providing positive feedback. It will cause to conduct this transistor in saturation state. When full current will flow in this winding, at that time magnetic field will stop to build, because when the current is changing magnetic field will build the voltage here. If it is from here to here, then it will stop, it will hold here. When magnetic field will stop building here, magnetic field in this winding will start to collapse. When it will collapse, it will produce reverse polarity voltage in this winding. Before this end was positive, but now this end will become negative. When it will become negative, it will cut off this transistor. Current flow here caused by the battery will cut off. At that time, this magnetic field will also collapse. When it will collapse, it will produce reverse polarity voltage. At initial stage, this end was positive, this end was negative, but now in the transistor off state, when IB is stopped, IC is stopped at the same time. At that time, voltage across L1, VL1, these will start to build up upside, positive voltage. So this end will become positive now. When this end is positive, this end will become negative. Now if we see positive, negative, positive and then negative. Two voltage sources are in series, but we need a current flow because collector to emitter junction is now open. For that purpose, a load is connected here. Any load. For example, we are connecting LEDs. So these voltage will drive this load until the voltage will reach at zero level here. When it will reach zero level, the magnetic field swing here that was going in negative side, now it will start to build up again because now it is also reached at zero line. And this time this winding is in reverse and magnetic field is now in reverse direction. When it is reverse direction, it will start to build positive voltage at this base again because these windings are opposite in direction. So this oscillation effect will move this transistor again in saturation. So again this current will flow here. When it will flow here, at that time, at saturation of this transistor, this winding will cut off. First, it will move this transistor in saturation. When magnetic field will build up at full stage, it will cut off this transistor. Saturation and cut off. Because this transistor is working in two stages, cut off or saturation. It is not working in linear, or very little power dissipation will there in this transistor. 20 turns, 22 turns in this winding and this winding. 0.1 millimeter or 0.15 millimeter. Let's make this circuit. You can use any ring core, ferrite core, a super core, super laminated core is good, which are used in EMI filter circuits, that are good, or filter coils, that are good. So I am using this core, and I am using 0.15 millimeter enameled wire. We will use two wires at the same time. First I will take measurement. One turn, two, 4, 8, 16, 24. I will take two pieces of wire. You can wind in any direction, both wires together. One, two, three, 4, 5, 10, 19, 20, 21, and 22. Now we have two windings. Both windings are in same direction. Now we will change the direction. Now remove the insulation. This is one winding and this is the second. We will use any one winding for primary and any one for secondary. We will use one end for this winding and one for this winding as a common to be connected at this point to make it in opposite direction. One winding starting end here, second winding starting end from the second side. One is starting from here, second is starting from here. So both windings will now in opposite in direction. This is now positive terminal. We will connect to battery positive terminal now. Now we have two ends. One will be connected to base using 1 kilo ohm resistor, transistor base C945. This end is base, center collector, and this one emitter. At the base we will connect 1 kilo ohms resistor, and we will connect to this winding. Now this end will come to collector, that is the center pin. First we will check oscillation and then we will connect the load. We will connect across this winding. One end at positive terminal, second end at collector pin, and we will connect to emitter. Yes, it is switching. It is switching at 231 kilohertz. And 43 volt peaks are there. 43, 42 volt without load. Now we will connect load. We will use approximately 20 volt as a load. I will connect LEDs in series to use as a load. I connected 6 LEDs. 1, 2, 3, 4, 5, 6 LEDs. Anode will be connected to collector pin. Anode of the LEDs will be connected to collector pin. And cathode will reach at emitter pin or negative pin. This pin will be connected at emitter. Once it starts oscillation, that time it will ring continuously. It will use just only feedback. Now 6 LEDs are turned on. This single battery is now driving 6 LEDs. Just we are using the magnetic field, stored magnetic field in the core. This time 21 volt are being produced using this circuit. And if we will check second winding, that is secondary winding, that is connected between base pin now both signals are opposite in direction. This is primary signal that is coming to the diodes, to the load, and this is base signal that is coming at resistor, and then it will come to base. Once the base starts conduction, base to emitter
current flows, it will allow emitter to collector current. That will produce voltage in secondary winding that are here. These will support the battery to move transistor in saturation. When transistor will move in saturation, collector current will stable, magnetic field will stop to build up, it will in expanded position. Now because the magnetic field is stopped to build up, secondary winding magnetic field will collapse. When it will collapse, it will move this transistor in cutoff state. When it will reach in cutoff, that time collector current will stop. When it will stop, primary magnetic field will collapse. It will produce voltage opposite in direction to the applied voltage. That voltage plus battery voltage will run the load. It consumes very little amount of current. Using this Joule thief circuit, we can run high voltage circuit, high voltage load using low voltage source. It is switching at 223 kHz. Same primary frequency and secondary frequency. I hope this video is informative for you. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.